Hello. In this video, we are going to be using L'Hopital's rule to find a specific limit relating to this function here. I just called it h of x so that we can use f and g comfortably later without, making any changes. But we just have some function that's equal to sine of x over x. And we're going to find a limit that has been featured as, kind of a celebrity in a few of my videos. So we're trying to find I'm going to write this in a different color because I like orange. We're going to take the limit as x goes to 0, so that is basically 0 is our k, x goes to some number, of the sine of x over x. And you probably already know this because you saw some other videos where I said what this was, but I'm going to show what it is using L'Hopital's rule. You prove it using the sandwich theorem, which is something that I guess we'll get into later. It's kind of cool. You draw a diagram, you look at some right triangles and a circle. That'll be fun, but for now, we're looking at the limit of, as x goes to 0, of sine of x over x, and immediately you know that if we just plug in x, x as 0, sine of 0 over 0, that's 0 over 0 if we just plug in x for 0. So we have an indeterminate form. Hence, we must use L'Hopital's rule. L'Hopital's rule. Exclamation point. There we go. So what did L'Hopital's rule say? Basically, it said that if this is the case, if we have some limit where when we just plug in that value for x and we get an indeterminate form, and we have the limit of, I'm going to write this down, I think. So no, that's not a good place to write it. Basically, L'Hopital's rule, given this, so just, I'm going to put a little asterisk here, because that's important. So, given asterisk, and the limit as x goes to k of f of x over g of x, f prime of x over g prime of x is equal to some real number L that we can determine, then our limit as x goes to k of f of x over g of x is also equal to L. Okay, so what's f of x and g of x? Well, I'm going to say that sine of x is f of x, right? It's in the numerator. I'm just going to say f of x. And I'm going to say that x is g of x. X is a function of x, right? It's just x. So let's see. Let's check, because if we find the limit of the derivatives of these functions as a quotient, like here, and it is equal to some real number L, then we will have found our original limit. Like, we want to find, the whole thing that we want to find, and I'm going to maybe write this in purple up here, or I'll write it down here actually. The limit as x goes to x goes to 0 of sine of x over x is equal to, and we are going to get an answer, spoiler alert, this is going to work out. So how do we do this? Well, what we have to do is we take the derivative of the top and the bottom. So what's the derivative of sine x? So let's just see, limit as x goes to k is a 0 of cosine of x over, what's the derivative of x? Or g prime of x, that's going to be 1, right? This here is just the same as this portion here for our example. Well, what does that equal to? If you plug in x as 0, this is going to be equal to cosine of 0 over 1, which is equal to 1 over 1. Hey, that's equal to 1. So now we've met the conditions. So we have some limit that when we just plug in the value that we're looking for is indeterminate. We got 0 over 0 right up here. And when we take the derivative of the numerator and the denominator, we put it in numerator and denominator form. When we take the derivatives of the numerator and denominator separately and make that fraction, and then take the same limit, we got our real value here, and that's our L. So now we can say overall that the limit of sine of x over x as x goes to 0 is equal to RL, which is equal to, or I'm going to write this whole thing out, is equal to the limit as x goes to 0 of cosine of x over 1, which is equal to 1. And this is our final answer. Our final answer is that the limit as x goes to 0 of sine of x over x is equal to 1. And you can try this with a calculator. You can make it on a graph. This should be pretty clear once you look at it in some other ways, but just solving the limit in the formal way wouldn't get you very far. This is the general use of L'Hopital's rule, and we know the specific limit from some videos. If you saw my proofs of the derivative of sine and cosine using the formal definition of the derivative, I'm not exactly sure if you saw those or not, but this is a pretty useful limit to know as it comes up a lot. I hope that this was helpful in your understanding of L'Hopital's rule and how it's actually used, and thanks for watching.